Hello and welcome to today's video on circles. This is going to cover topics in the standard 2.6 in geometry and under that study island topic called circles. So if you're working in either of those two places, this is the place you want to be. And there's going to be two parts to this topic. So this is part one. So if you're working in either of those places, you're going to want to make sure you watch both parts. There's a lot of rules to circles and a lot of patterns that you just have to know. So practice makes perfect, and just make sure you're taking good notes so you can also have those to study from. And anytime you're watching these videos, remember you can pause, fast forward, or rewind. You can, you should be taking notes. So if I go too fast, just pause, catch up, and then join us back. And then also you can pause at the beginning of a question and work the problem out, see how you did, and then check it with my work. So I hope you are having a great day, and I'm glad you're here. Before we begin, I want to go over some vocabulary that will make these questions easier to understand. So first of all, a circle is the set of all points equidistant from a given point called the center. So that means if you have a center and you go equal all the way around, distance away, then that is how you create a circle. So, and then we have a radius, which is from the center to the edge of the circle. We have a diameter that is from the edge to edge and goes through the center. And then we have a chord that goes edge to edge, but doesn't necessarily have to go through the center. The diameter is a type of chord. However, a chord isn't a diameter all the time. It doesn't have to go through the center. Okay, then we also have minor arcs and major arcs of a circle, and that's talking about the outside perimeter or circumference of the circle. So a minor arc is if it's less than 180 degrees, the measure of it, so it's less than half of the circle. And then the arc that measures greater than 180 degrees is a major arc, so it's over half the circle. And then if you have one that's exactly 180 degrees, so exactly half the circle, then that's called a semicircle. The last two vocabulary words in this video are central angle and inscribed angle. So these are angles inside of the circle. A central angle, the vertex is on the center, and an inscribed angle, the vertex of the angle is on the outside of the circle, on the circle itself. And so there is a pattern that these follow every single time. A central angle, the arc measure and the angle, they're always going to be the same. So here the arc is 45 degrees and the angle is 45 degrees. That pattern holds true all the time for central angles. An inscribed angle, it's always going to be half the arc. So the arc measure here is 90 degrees and the angle measure is 45 degrees. The inscribed angle is always half of its corresponding arc. So those are the two rules that we need to learn and memorize and know for the following questions. This question here says, what is the measure of the angle TRK? Well, I know that this central angle is 72 degrees. So then I know that the arc is also 72 degrees. And then I know that an inscribed angle is half of its arc. So half of 72 degrees is 36. So my answer here is C, 36 degrees. Okay, this problem says the measure of arc MP is 80 degrees. So that means from M to P is 80 degrees. The measure of angle MAP, that's what it wants to know here. So MAP is an inscribed angle. I know that an inscribed angle is half of its arc. So that means half of 80 is 40. So my angle measure here is 40, letter A. The center of the circle is Q. So it wants to know what is the measure, and this curve symbol here means arc. So it wants to know what is the measure of arc TU. So it wants to know what is the measure of this piece right here. Well, I need to know a central or inscribed angle to be able to solve that. Here I have central angles. I know that this one is 100 degrees. And I know that half of a circle is 180 degrees. So this diameter here, this piece and this piece are going to equal 180 degrees. So if I have 180 degrees, but I already used 100 up, I'm going to subtract that off, and I'm left with 80 degrees. So that means this central angle here is 80 degrees. So that means my arc is also 80 degrees. So my answer here is going to be C. So here it tells us that the center of the circle is Q, and we know that triangle RQS is a right triangle, which they've marked for us. And it wants to know what is the measure of arc RTS. So RTS is this arc right here. It wants to know what is the measure of that. Well, I know that this angle here is 90 degrees. I know that central angle and this arc are going to match. So arc RS is also 90 degrees. I know there's 360 degrees in a circle, and I've used 90 degrees of that up. So if I subtract that from 360, that leaves me with 270 degrees. That means the rest of my arc that I'm looking for is going to be that 270 degrees. So my answer here is C. So far, all the questions that we've been working on have asked us what is the measure of an arc in degrees. Well, sometimes it's more useful to know what is the measure of that arc in length, so centimeters, inches, feet, than it is to know what it is in degrees. So in order to find that, we have this formula over here to calculate that. And basically what it is it's taking one side, it's taking the length, and the other side, it's taking the degrees. So over here, it's the piece of length over the total length, because this is the circumference formula. And on the right, we have the piece of degrees, the arc measure, over 360 degrees, which is the total degrees of a circle. So if we know the radius of circle R is 12 inches, what is the arc length of QS? Well, if I'm going to use my formula, I'm looking for arc length, so I'm going to put an X on the top, and then I have 2 times pi, and you could write 3.14 instead of pi if you wanted to, and then I have R is for radius, which they tell me is 12 inches, so this is going to be times 12. And I can use parentheses to show that substitution. Equals, and this part here wants the measure of RQS, which is this piece here. That central angle is 60 degrees, so I know the measure of that arc is also 60 degrees, so I'm going to put a 60 here over 360. And so now I'm just going to cross multiply. So I have 360 times x is 360x, and then I have 2 times pi times 12 times 60. Those are all numbers, so I can just do that multiplication. Now, I looked ahead and saw that I have pi in my answer. So I'm going to leave the pi in my calculations. I'm not going to convert it to 3.14 because it stays in my answer. So I'm going to take 2 times 12 is 24. And then 24 times the 60 is 1,440. And then I still have that pi. And now I'm going to divide both sides by 360 to continue solving. And those cancel, and I'm left with x equals, and then I'm just going to do this 1440 divided by 360 on the calculator, which is 4, and then I just bring the pi down with it. So that means my x, or the arc length here, is 4 pi, and my answer is B. Okay, this question says, a circle has a radius of 2 inches and a central angle of a measure of 1/3 pi radians. What is the measure of arc length associated with this angle? Well, here they don't give us the formula, so I've copied over the formula from the last problem. However, the last problem here dealt with degrees. This is dealing with radians. So a circle has a total of 360 degrees, and it also has a total of 2 pi radians. Now, the difference, you know, when you measure something with a ruler, you could use centimeters or you could use inches. You could use yards or you could use meters. There are 2 ways of measuring the same thing, just different units. Degrees and radians are the same way. So if I'm going to be using radians, I need to make sure that my total here is in radians instead of degrees. But otherwise, this works the same way. I'm working and looking for arc length. So that's going to be my x. And that's over 2 pi r. And my radius here, they told me, is 2. So I'm going to substitute in a 2. Okay, they told me my angle measure of the central angle, which always matches the arc measure, is 1/3 pi. And that's over a total of 2 pi. Okay, so I'm just going to go ahead and solve this. The first thing that I see to do that's going to make this problem easier is there's a pi in the top of the fraction and a pi in the bottom of the fraction. So I can simplify that by canceling them out, since there's one in the top and one in the bottom. All right, so then I'm going to cross multiply. I have 2 times x, which is 2x. And then I have 2 times pi times 2 times 1/3. I'm looking ahead and see I have pi's in my answer. So I'm not going to cancel out I'm not going to use 3.14 for pi. I'm not going to replace it with that. I'm just going to keep it going in my problem. So 2 times 2 is 4. And 4 times 1/3 is 4/3. So I have 4/3 pi. And then my last step is to divide both sides by 2. And these cancel. And 4/3 divided by 2 is 4/6 pi. However, that can simplify by dividing a 2 and out of the 4 and 6 and gives me 2/3 pi, which is my answer in letter D. Okay, this problem here is very similar. They tell us that the length of QR is 3.5. But this time they're asking for an angle, and they're asking for angle RQP, which is this angle right here, instead of asking for the arc length. Well, I know that this angle and this arc measure are the same because central angles and their arc measures always match. So that means if I solve for the measure of arc RP, that's going to give me my answer. So that's going to be where I'm going to put my x when I'm looking into my equation, because that's what I'm solving for here. So the problem tells us on the circle that the arc length is 0.7 pi. So I'm going to substitute that in for my arc length of arc RP in the top of the first fraction. And then I have 2 times pi times the radius, and the radius is 3.5, they tell us in the problem. And then I have my x already, and then I just have the 360 underneath. So right off the bat, I see I have a pi in the top of this first fraction and the pi in the top of this first fraction. So since it's all multiplication and division, I could just go ahead and cancel those out. And then I'm going to go ahead and just cross multiply. So I have 2 times 3.5 times x. 2 times 3.5 is 7. So it's going to be 7x equals, and then I have 0.7 times 360, which is 252. And then I'm going to divide both sides by 7. These 7s cancel out. And I'm left with x equals 252 divided by 7 is 36. So that means my arc measure here is 36 degrees, and my answer is B. Thank you for joining us today, and I hope you learned something new.